Our next speaker is Renan Sakonos. He's an agriculture manager. He's from Fairview, Virginia. Tennessee, right?
Yeah, Tennessee.
Tennessee.
Yeah, awesome. Thank you so much. Awesome. Can everyone hear me okay? Awesome. Do you know, is the slideshow loaded up? I can send it to myself real quick.
There you go.
All right. And so I've become a Google person and lost track of PowerPoint. All right, thank you so much for having me here. Is this working? Yeah, my name is Renan Sokolov. I work for Propagate Ventures. I got started in agriculture back in 2013, 2012 when I was at Cornell University. I was a neuroscience and philosophy major who decided to take a job for a plant breeding professor for one summer and just fell in love with it and have been doing it ever since. Moved down to Tennessee back in 2017 and was managing the vegetables and agroforestry operations at Caney Fork Farms in Carthage. And then just this past February, started working as the agricultural project manager for Propagate Ventures. So to take a step back, I always like to start with this of what the extent of old growth forest was in primarily the eastern United States. And so much of what, at least what I used to think of as the Great Plains, was forested at a certain point up through 1620 more or less. And really the 98th parallel where rainfall kind of stops is really where trees ended. And you can see how much tree cover we've lost from 1620 to 1920 and obviously now till 2020. And one thing that I once heard a quote from one of the early European settlers coming over the Highland Rim and looking down into the Nashville Basin and just being at awe of the bounty of the elk and the bison that were grazing along these chestnut and pecan groves. So really looking at this savanna-type pasture that fed tons of people for generations and thousands of years. And there's been a lot of downsides of removing all these trees to make way for our annual crop production that we currently have. We have erosion, stream impactments, we have fertilizer runoffs, we have just an overall loss of biodiversity and wildlife habitat. So really now I think we're at a point where we're seeing that there are these negative outcomes of removing trees from the landscape, and yet we have these caloric needs that we need to meet and also economic needs that we need to meet from our farming systems in our modern day. So how can we start bringing trees back into the systems while still meeting all of those criteria? So really simply, agroforestry. The USA defines it as the intentional integration of trees and shrubs into crop and animal farming systems to create environmental, economic, and social benefits. And I think it's really important to point out those environmental, economic, and social benefits. I think we all have the dream that all three of them are all going to be hit at all times. And sometimes that's the case, and sometimes that's not the case. We're not always going to be able to find economic benefit or direct economic benefits from planting riparian zones, so planting acreage around waterways. There are all these benefits of phosphorus reduction and nitrogen reduction that come from that. However, until we have environmental outcome marketplaces that can pay people for that, there's not an actual crop that you're getting from there. It's great, but at this day and age, we're not getting actual payment for that. So really trying to break down where are we expecting to see economic gain from, and then where are places that we as a society hopefully will start to value these more and pay producers to implement some of these practices. So I'm going to touch a little bit on the practices 1 through 4, forest farming kind of put aside for now. And so here are some of the benefits of agroforestry in general. So despite not wanting to reduce agriculture to or environmentalism to specific molecules, there is a lot of carbon that can be sequestered through agroforestry, between 2 and 8 tons of carbon sequestered, depending on the amount of trees, the species of the trees, and the practices that are put into place. A lot of these systems are more high-touch systems from a lot of agricultural systems currently. So that has its negative outcomes, but also has a positive benefit of if we can unlock the economic potential of these, it has the potential to open up more rural jobs. We have nitrogen runoff reduction, phosphorus runoff reduction. You actually see larger tree sizes in a lot of agroforestry systems as compared to a timber plantation. So if you're looking at it from a high-value timber production standpoint, you can actually get more money by having fewer trees and more management. And then also for a livestock-centric focus, this was from a study down in Florida, but they were finding that they were having yields or weight gains of 1.4 pounds more per day in the heat stress times of the year. So just from that heat and wind stress reduction, they were able to really see that benefit for the livestock. Silvopasture, we'll start diving into that a little bit as a specific agroforestry practice. And this is really combining trees and livestock with the forages on a single piece of land. And again, I think it's really important to separate out, are we planting trees for the benefit of the livestock, or are we planting trees for a separate operation? And I think, as Buck mentioned before, I think he did an incredible job on his farm of, if we're looking at it from an operational standpoint, it's one thing if you're coming and saying we want to plant trees to benefit the livestock. There's a handful of things we need to take into account. The establishment protocols, how are you planting them so that the cattle aren't eating them and killing them in the early years? How are you planting them to make sure that you're not reducing your overall annual forage production? And then also, how are you choosing the best species to have the most perennial forage and mass production? So thornless honey locust, even with some of the negative aspects of it, does produce a ton of mast for particularly sheep and also cows. If you're looking at fodder crops, those types of things, they don't take a lot of management past those first couple of establishment years. Whereas if you're looking at saying, hey, I want to plant a chestnut orchard and I'm going to graze within that chestnut orchard, you can do that, but you have the establishment protocols, you have the same annual forage production questions that you have, but then you also start getting into food safety and exclusion questions. So anything that might have any food crop that might come in contact with manure, you'll always need some regulations around that. If you're certified organic, there's just a very strict 90-day exclusion period that animals cannot be in that field 90 days before harvesting, which again is okay, but if you are planting your entire acreage into chestnuts or some sort of edible crop, all of a sudden 90 days before you're going to harvest, it's, I don't have anywhere to put my cows or put my sheep. So really planning out your entire system to make sure that you're accommodating all these different operations. And then in addition to that, if you're doing chestnuts and you're doing it at scale, you need equipment, you need the harvest protocols. The people who you sell your beef to might not be the same people who you're going to sell your chestnuts to. So there's a lot of operational know-how that goes into there that you need to consider. So Propagate Ventures. The goal is really twofold. One is to make accessible all of the operational know-how to learn how to plan these systems, but then also to give you a good 30-year roadmap so you understand what this is going to look like, how it's going to affect your existing operations, and how it's going to affect any new operations that you're adding into it. So this is kind of the evolution of Buck's crayon drawings here, is using GIS tools and a mapping software called Overyield that Propagate has developed and just released this past year. And we'll do, let's hope this works, a little video presentation of me designing a field. Nope. Uh-oh. Uh-oh. I think it's trying to take me to we're going to do a quick move. No. Okay. Not exactly the video I was going to show, but we'll try to make a quick pivot here and show a different promotional video that we have for the software. If it's still on the website. There we go. Oh, no. Oh, sorry. All right, here we go. And while you're watching, I can kind of walk through a little bit more of the features that I was going to show in a separate video. But basically, what we've created is the ability to go in and create. To start with, we'll take a new field and put in all the infrastructure. So you have the ability to draw in current roads, future roads, irrigation ponds, fences, all these different sort of features. And then these green lines here, we're calling it a headlands feature. So you can basically go in and you say, okay, I want to be 30 feet off of the forest edge. I want to be 30 feet off of these roads. And then you can draw that, and then you can draw the fields in there. You can then go in and select. We have 25 different crops that we have economic models for. So you can select from those 25 different crops there, draw the fields. You can get down to row by row level specificity. So here you can, not sure what crops they're changing those to, but you can do alternating rows if you want to add in biodiversity rows. If you want to leave certain rows out because you want some larger pathways to go through, you're able to do that. And we'll dive into some more of the economic outcomes that we have in here also. And then on the design side, a few other things. We have the ability to separate out the exact planting years of different sections. So especially on a lot of our larger properties, we're recommending that people plant over a 2 to 5 year period. That way, if there is a drought the first year, you're not risking 100% of the trees you're planting. And also, you get to know your site better. You can start to see what species are doing well, what species might not be doing well, and then pivot in those later years. So basically, once you draw, I'll go back here. Once you design the whole farm, and I think that covers most of it, but essentially imagine bringing in all of the ArcGIS tools that a lot of very knowledgeable, sophisticated computer programmers are able to use, taking all the features that are really relevant to designing farm silvopasture systems or farm agroforestry systems, and then in a really simple, easy to use tool that if you have the ability to use a Google Earth style thing, like that's really the level of simplicity and ease that we've created with it. So once all that is done, we have all the economic models on the back end that we work with the landowner or work with the producer to customize for them. And then after that design is made, it will basically be run through all of our algorithms and automatically output all of the economic predictions that we have. So the first thing you'll see is just a high-level summary page. You can look on a whole farm basis. You can see where the break-even years are. You can see the rates of return. You can see 5, 10, 15, 20, 30-year predictions. And then you can get lower down into a crop-by-crop level specificity of what your system will look like from an economic standpoint. You'll see yields. So yields, right now we're just looking at fodder mulberry. That's a pretty simple one for us to model just in terms of what is the dry matter amount of fodder that will be produced of that system. Black locust is being used as a timber crop in this system, so we're looking at the number of board feet. Mixed fruit is primarily modeled off of peaches in this model, so it's just how many pounds of fruit are coming off of this. You'll see down below that there is the silvopasture mix has 0 pounds of return. So for right now, we are leaving it at that. Our hope is that we're working with a number of university partners to start putting together some really hard economic data around what are the economic benefits to the cattle or to the livestock that you can expect to see from planting trees. It's a little more complicated than just so like persimmons, we could model how many pounds of persimmons are coming off of that and how much would you have to pay for that calorie density essentially. But being able to model the weight gain from heat stress reduction, from wind reduction, that gets a little bit more, there's just a lot more variables there, and it's more of an indirect revenue stream as opposed to here's a crop and you're selling it there. So for revenue, for fodder mulberry, for example, we've basically compared that to if you had to purchase in that amount of hay and mineral supplements to offset the amount of fodder that you'd be producing, that is sort of the cost that we're predicting there. On the operation side, the way that we model all of our crops is really getting down to the minute level. So we're talking to the producer about what size tractor are you using, what size mower are you using, and then we're plugging that into our system so we know, okay, for you to mow the row edges of this crop is going to take you 7.32 hours every single time you do it. And then saying, okay, how many times are you expecting to do it? And then really working through all the logistics. So you're both getting the economic data, but because we're getting so minute in how we're modeling this, it really becomes just a how-to. So it's like this is the operational plan year over year for the entire system. And obviously for something like fodder mulberry, there's the installation, there's more work there, but then in later years, maybe you do a cleanup mowing, maybe you do you go out and knock off, you cut down any trees that are getting bigger than the sheep or the cow are able to get to because they didn't get to it, but there's really not a whole lot there. Whereas if you're doing a chestnut or elderberry operation, obviously the management and harvest and the marketing are going to be a lot more filled out. Then the labor side, it's the same thing as the operations page, except instead of on a dollar amount, we're just putting in a pure hour basis, and we found this is really helpful. I came primarily from a vegetable world before getting into tree crops and just didn't really have a concept of, I know how long it takes to prune tomatoes, I don't really know how long it takes to prune a timber tree. So by giving some of these data points, we can really help producers have a sense going into the season of, okay, am I gonna need to get 5 people here for a full week in order to get all this pruning done, or can I have 2 people kind of do this and chip away at it over the course of 2 or 3 months? We also have an inputs page, so this is essentially the shopping cart for all 30 years of the entire system. So again, for more silvopasture crops, this will be pretty extensive in the early years, but then later on, you're not purchasing anything afterwards to implement it. But for, again, chestnuts, you are going to need to be purchasing crates for harvesting. You'll be purchasing $5 bag or 5-pound bags in order to sell. So really getting down to the detail again of all the different inputs that are going to have to go into running the system. We have a capital expenditure page, which again is going to be really dependent on the grower. What equipment do they already have? What infrastructure do they already have? Some producers want us to include processing buildings and things like that. Other of them don't want to include that, and they're kind of eating those costs separately from their business, and they just want to see the operational costs. And we also have the genetic costs. So how much is it going to cost to purchase all the trees for this farm? And then lastly, we have a carbon page. So this is from some studies at Guelph University looking at the total amount of carbon that is stored in the above ground and below ground biomass. Below ground biomass is just the actual root structure, not the soil organic matter. But as carbon markets become more and more developed, this is a way that you could sort of bridge that gap and see how much carbon you could be sequestering throughout your entire property. So why are we doing this? And this is kind of the answer, is to get more systems planted. This is a system up in the Hudson Valley of New York. It's primarily a chestnut and blackcurrant operation. There's a neighbor who has cattle who's been haying in between the tree rows the past couple years. And we have plans for him to come in and do some sort of prescribed grazing on the property once the trees are above a certain height. But this was it was a landowner this was old family land. It was it was really actually just sitting there fallow, and he was interested in doing something beyond just leasing it out to a conventional soy and grain farmer. So with having all of this information really helped them make that decision to go out and plant trees that are going to be there for 60 to 100 years. So I'll get just real quickly, so this is a case study of a farm down in Texas. It is a sheep grazing farm. So to kind of take you through some of the ways that we like to work, this is actually a new property for them. It's about 150, 160 acres total. And So to start with, they have this little green section right here is a U-pick mixed fruit orchard. They have a number of development houses going in around them. So they felt that 2, 3, 5 years from now, a lot of people will be really excited to come onto the farm and do U-pick operation. Then all the orange fields are silvopasture fields, actually pretty much the exact same mixtures that Buck used on his property, and with the goal of we'll thin those out over time. And then we have these purple lines are fodder mulberry strips. So they decided that they wanted to plant them along the fence rows so that basically there'll be hard fencing around this field right here, and then they'll use just polyline to strip graze this entire field. And they really like the idea of having fodder crops available to the sheep in every single paddock and throughout every rotation. And then lastly, there's this 10-acre black locust timber plantation essentially. So that's planted really densely at a 10 by 20 spacing, and they were really excited about it. One, they have a sawmill down the road that said that they'd be happy to work with them on this, and they were excited about the returns on the timber itself as a long-term investment, but they were also looking at this as a living barn. So they are, obviously in Texas, it gets very hot. They are managing it really intensely so that they're actually going out at certain times of the day and moving the sheep into shaded areas for 3 hours during the day and then moving them back into the pasture. So they really love this idea of being able to build a really dense timber plantation that they can move the sheep into for just certain parts of the day, or if there's a big winter storm coming in, they can move them in there, get them a lot of protection from the cold and from the wind elements, then they can move them back into the field during better weather. So again, I think I've talked to a lot of people who either have the idea or have been pushed to the idea of, oh, just plant trees everywhere on your property and plant everything with something that's going to produce a human consumption good. And I think this is a really good example of we really want diversity on all of our farms. And if you planted this entire property with that 10 by 20 black locust planting, you're not really going to have any forage like 3 to 5 years from now. So animals are not going to be very happy, but by placing a certain percentage of it into a zone like that, you can really then start to build out the different areas of the farm that each have different functions and different purposes that can complement each other as they're grazing throughout it. So I think, 21 minutes. I have one other case study I can go through. I'm happy to open up to questions first and then get to that case study afterwards if we have time. And here's my contact information if anyone wants to get in touch afterwards.
I have a strange question. The earlier part of the slide or your presentation, you're showing numbers for carbon, nitrogen, and phosphorus, production of runoff or anything else like that. I was going to say, do you have any numbers for potassium, like its retention, its anything of that nature?
I actually have never seen potassium runoff, and I'd be curious if there's a soil scientist here who could maybe speak to why that, if potassium doesn't get into the water, isn't as water soluble maybe or something?
Well, I'm not talking about runoff. I was just saying potassium and its relationship.
Oh, gotcha. Gotcha. No, but we don't have any numbers like that. And those numbers, I believe you're referring to, were the phosphorus and nitrogen runoff reduction by planting. Those are actually from riparian plantings that they studied that can reduce the amount of phosphorus and nitrogen that gets into the waterways by having those plantings there.
Yeah, I have a question.
Yeah.
Do you have, when you go to these farms, do they plant like fruit trees?
Yeah, so we have, so like the farm is down in Texas, they have just a 5-acre mixed fruit plantation, or mixed fruit orchard, sorry. We have some other clients who are interested in larger acreage fruit production, and we're able to work with them also for this.
Okay.
Yeah.
Any more?
Are those fruit production orchard spots, are they grazing sheep or cattle?
Not yet. One of them I know has plans to, but they are planting next year, so they haven't gotten to that point yet. Yeah. I guess also just to give a little more context to Propagate. So we've created this software. We're currently working a little bit more as like a standard consultant. So if you had a property that you're interested in working with us in, you would basically pay an analysis fee, and then we would use the software to help design the property. The goal probably by this time next year is that we want to build out the software to the point where all of that customization of what type of equipment do you already have, what management decisions do you want to make, the customer would be able to input those themselves into the software itself and be able to make all of those changes. Right now, it requires us to do that work on the back end for it to show up on the front end. But the goal is so that people could really do more of a self-guided consultant tour through this. And that will also bring down the cost also a lot for people who need some of the information but don't need us to necessarily help them design the farms.
Any more? Okay, thank you.
Thank you all very much.
Hey.